Okay, question 17 asks us an A to solve from length TR. So I mean the length of this side here. Okay? Now remember I said we're used to renaming the triangles so that it fits into our formula. So I'm going to quickly just redraw it over here. But instead of STR, I'm just going to rename the triangle. Now, because we're trying to solve for this side over here, with our cosine formula, we're going to call this angle C and this side C. The A and the B from there, I can just choose either one. We'll still end up with the right answer. So I've now relabeled it.
3 B's. Again.
Are there? Again? Oh,
41.
there you go.
The blue.
Thank you. There you go. So we've renamed the triangle. We can put it into our formula. So our formula is C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. So we're going to quickly take a look at this. The length of side B is 41. So for both of the B's, I'm going to be plugging in the number 41. I'll write it on top just so you guys know. Side A is 25. So both of the A's, I'm going to be plugging in the number 25. And finally, our angle C is 70 degrees. So for the angle, that's the large C at the end of the equation, we're going to plug it into there. Okay, so let's rewrite this equation. C squared is equal to 25 squared plus 41 squared minus 2 times 25 times 41 times cos of 70. Okay? 71? I think it's just 70. 70. Did I write it as 71? No. Okay, so this is a good reason why you're going to need a calculator in this course. 25 times 25, 625. Plus 41 by 41. Is that right? I guess so. 1681 minus 2 times 25 times 41, 2050. And I could also equate cos 70. So 70 cos 0.342. So times 0.342. So now that we've done that, according to BEDMAS, make sure that we multiply this. Okay? And in fact, there's a negative sign in front of it. So it's almost like negative 2050 times 0.342. We would add these two together also. We'll do this one step at a time. C squared is equal to 625 plus 1,681. And we take this times 2050 negative. We get negative 701.41. Negative 701.41. So now that I've multiplied this, I can now add these numbers together and then subtract this value. Make sure you multiply this first though. Don't just take the 2050 and subtract it from those two numbers. C squared is equal to 625 plus 1,681, 2306. Subtract 701.41. $16,004. C squared. And finally, to evaluate that, we need to square both sides because C is squared. So we take the square root of this value. We're going to say approximately 40. So C is approximately 40 feet long. So we go all the way back up here. Side TR is 40 feet long. Okay? That's 17A. So, one more time. The reason we knew we couldn't use sine law is because we didn't have the measurement of an opposite side and an opposite angle. So, 25 was this side, but I didn't have the measurement of this angle. 41's measurement of this side, but I don't have the measurement of that angle. And finally, I have the measurement of angle S, but I don't have the measurement of that side. Because I don't have any of those opposites, like a C and a C, an A and an A, or a B and a B, I can't use sine law. I have to revert to using cosine law in that sense. So make sure you know which of the laws to use when going through this. Okay, so part B to this question then asks us for the angle of elevation, which is actually angle A according to what we've set up. So they're asking for angle A. I could use cosine law again to solve that because I do have the measurements of all the sides. But in my opinion, cosine law is the hardest of the laws used. Now that I have this measurement of 40 feet and the opposite angle, I can use sine law, which is a little easier to set up. So if you guys remember sine law, sine of angle A divided by side A equals sine angle B divided by side B is equal to sine of angle C divided by side C. So what I'm going to quickly do now is I'm going to plug in the information. So side C's angle is 70 degrees. And side C's measurement is 40 degrees.
I have it written down.
So I'm going to replace the C was 70 and the lowercase c was 40. Side A is 25 feet. So I'm going to be replacing side A with 25. And side B is 41 feet. So replace side B with 41. So I'm replacing these specific variables with the numbers just above and below them. So I'm going to rewrite it now. So we have sine 25 divided by A is equal to sine B divided by 41 is equal to sine 70 divided by 40. Okay, so I do have one of the ratios. Like we said, we have to have one ratio to use sine law. The only thing is I need to cut out one of the other ratios. What am I actually trying to solve for right now? Oh, gentlemen, I plugged something in wrong here, if you notice. This 25 should be here. It's not the angle that's 25. It's all right. So we're trying to actually solve for angle A, which is that variable there. So what that means is I actually don't need the middle ratio, sine B divided by 41. That's unimportant to this question. So I'm actually going to drop it from the ratio, and I'm just going to leave this as sine A divided by 25 is equal to sine 70 divided by 40. Now that we have that, I'm trying to isolate A. So I need to move 25 to the other side of the equation. So I'll be left with sine A is equal to sine 70 divided by 40 times 25. When I move 25 to the other side, it becomes multiplied by because it's a division sign over here. So let's solve what that bracket says. Sine 70 divided by 40. 70 sine divided by 40. 0.023. And because of the way my calculator is set up, I can just quickly multiply by 25 to get our final sine A ratio, 0.587. Almost. So I have the ratio. But what are they actually asking me for? The angle. So they want just A by itself. So I need to bring sine to the other side of the equation. So this will become A is equal to sine inverse of 0.587. So we take that, shift sine inverse, 35.9. Whoops. 9 degrees. So we've discovered that the angle of elevation in the question, I've already forgotten. What is it? 35.9. 35.9 degrees. So I started with cosine law to find the side. Once I had the information, I could use sine law. And finally, what if I wanted to find the last missing variable of this triangle? What am I looking for? B what? Side or angle?
Angle.
Angle. How can I find that quickly?
180.
Take 180 and subtract the other two angles. So we get 110, subtract 35.9, and our last angle is 74.1 degrees. So angle B, 74.1 degrees. So I've now solved everything in this triangle. So these are two definitions that I actually assumed you knew, but I shouldn't have done that. If you have something set up like this, where you have a horizontal line and then an angle heading at a downward direction, this is called an angle, yes, of depression. Also, if you have a horizontal line and then you have an angle heading in an upwards direction, this is called angle of elevation. Is that right? Okay, so if you get that on a test, and the question says the angle of elevation is 42 degrees, construct a triangle, that means you need to be able to construct a triangle that looks something like this. If the angle of elevation is from left to right, then this would be our angle of elevation. If it's from right to left, then it would be the other one here because they both touch a horizontal line. Okay?
So if you're on
So let's say you are, for some reason, standing on a cliff. Okay? And you're looking down at a wonderful boat. The boat's on the lava. And here's Michael. Michael's out of uniform, so here's he. There you go. This is pants. I'm not sure why he's close to see-through, but... Okay, and anyways, Michael is looking down at the boat, and they ask for the angle of depression. So, his eyes are here. He's looking down at the boat. Many people will think that the angle of depression, sorry, I'm just going to draw this in here, is this angle here. That is not the case. You draw a straight line from the point we're looking at, so it needs to be horizontal. The angle of depression would be this angle in here. It is not a made-up angle here. You must draw a line straight from the point you're at, horizontal, both times. Don't draw a vertical line from there. Horizontal line. Angle of depression. The other one, wrong. I think that's the name. Okay? Angle of wrong. I'm not sure what it's called, Sampras, if they have a name for it. Okay, question number 8 says, now in the quiz it says necessarily. I replaced it with for sure because I realized some of you guys didn't understand that I wanted to know which of them has to be an acute angle. Okay? So, when we're looking at this, what we need to remember are our quadrants. and that cast system I showed you. Remember we had C, A, S, T. Quadrant 1 is acute angles. Okay?
Yes, sir.
Quadrant 2 are obtuse angles. So the question says, which must be an acute angle? So first off, if I have a negative of either cos ratio or tangent ratio, which quadrant am I in? I'm either in quadrant 2, maybe 3, or maybe 4, right? But I cannot be in quadrant 1 if I have cos as negative or tangent as negative. In other words, they cannot be acute angles. So right away, I know this can't be B or D, because if tangent or cosine are negative, they're not in quadrant 1, because all ratios are positive in quadrant 1.
Sir, can I put that on my sheet? Should I draw that?
Sure, of course you
Put
can.
anything on
As long as you show me first. Now, in terms of an acute and an obtuse angle, cosine and sine. My sine ratio potentially could be an acute angle because it's positive, but it could also be an obtuse angle because in quadrant 2, sine is positive. So because of that, I'm unsure on whether sine A is equal to 0.026 is an acute or an obtuse angle. Okay? So I'm unsure about that, so I'm just going to give it a little question mark. I could probably actually get rid of it because it's potentially an obtuse angle. Cosine being positive, because remember, we're only really working in quadrant 1 and 2. If cosine is positive, it can't be in quadrant 2, which means it must be in quadrant 1. Therefore, cosine A is for sure an acute angle. C is ambiguous. We're not sure, so we have to get rid of it. I can't tell if it's acute or obtuse, so I can't say for sure that it's an acute angle. So we take that off of the market. Okay, question 4A from your review. They've told us that there is a lot that has two perpendicular streets connecting at a corner, which means they're going to create a right angle. One of the lots extends 450 feet, the other lot extends 350 feet. They want to know what angles each of the streets make with the lot. So in other words, they're looking for the other two angles. Now, I'll be using my trig ratio. So I'm either using my sine, my cosine, or tangent. I have to look at each angle. So let's say I'm going to name this triangle again. Call it A, B, C. Let's say I'm working on angle A. According to angle A, what measurements of the triangle I have? I have the opposite, and I have the adjacent. So which ratio do I use? That's right. We're going to use tangent ratio because it deals with opposite and adjacent. So we're going to set this up. Say we're working on angle A. So I'm going to say tan of A, that's the angle we're looking for, is equal to opposite, which is 450 feet, divided by the adjacent. It's 350 feet. So, tangent A is equal to, we're going to do 450 divide 350 becomes 1.28 as a ratio. And then I need to move tan to the other side. So tangent to the inverse of 1.28, because we're trying to isolate just the angle, will become 52.1. So our first angle A is 52. We're going to round it directly to 52. Once I have the measurement of one of the angles, two of the angles of a triangle, how can I quickly find the third?
Minus 180. Well, 90 plus that plus minus 180.
Okay, so I add the two angles I have, which are 52 and 90 degrees. So 52 plus 90 degrees is going to be 142 degrees. And then I take that number and subtract it from 180. 38. So angle B is 38 degrees and angle A is 52 degrees.